Hi, in this lab I modeled the motion of a gymnast performing a two-flip aerial skill using VPython. Purpose of the lab was to model the motion of a gymnast, Gabby Douglas, performing two full flips, rotational motion, and forward movement, which is translational motion. The lab used VPython to code and Gabby Douglas's 2012 Olympic bar performance on YouTube to visualize how rotation and translation occur in gymnastics. The physics concept used was translational motion, which we calculated velocity equals distance over time. Kinetic energy equals 1/2 mass times velocity squared. Rotational motion was omega equals 2 pi times the number of rotations over the total time. And the kinetic energy used moment of inertia instead of mass and omega angular velocity instead of velocity. To update omega, the equation theta equals omega times time was used, and to calculate angular displacement, change in theta equals omega times the change in time was used to update it slowly. To simplify the code model, some assumptions needed to be made. First, the distance traveled was estimated based off of her height in 2012, so we got 3 meters by estimating that the distance was around 2 of her height, which was 1.5 meters in 2012. Air resistance was ignored. We assumed a constant horizontal velocity. It was a rigid body model, and the total flight time is calculated from video stamps, which was 1 second overall for the two flips. In VPython, I created a compound object using a sphere and an arrow to represent the gymnast's body and orientation. The mass was 40.8 kilograms as well. In my model, we took the distance, which was 3, over time, which was 1 second, to get a velocity of 3 meters per second. In the code, this was represented by this, which shows that there was forward motion during the flips. The velocity was constant since we're ignoring air resistance and horizontal forces. And the line constantly updates the position, so every time step, the gymnast moves forward slightly based off of the velocity calculated from the video clip. Gabby Douglas did 2 flips in the clip that I found on YouTube. 1 flip is equal to 2 pi radians since it's a circle, and then 2 flips is equal to 4 pi radians. Therefore, omega is equal to 4 pi over 1 second. Rotation in the code was used this way, and she's rotating around the z-axis, which is why the vector is 0, 0, 1. I was updating the angles slightly by multiplying omega times the dt to get the new theta. This also means that theta stores the angle that's rotated over time. So instead of jumping directly to 2 flips immediately, the model builds rotation slightly and slightly until it reaches 4 pi radians, which is what we calculated based off of the equation that I provided for how to find omega at the beginning of the video. This model properly showed how 2 perfect rotations happen with constant translational velocity with no energy loss. However, the real gymnast, Gabby Douglas, did have slight variation in spin speed, and because of the fact that in real life there was air resistance, and her body shape does change mid-air due to tucking as well as different movements, but because of the fact that we had to make a simplified model, it's constant to ensure exactly 2 flips occur in 1 second. To consider these physics concepts on a bigger scale, 2 what-if questions was theorized. One was, what if she tucked in earlier? This would lead to her rotation speed increasing at an earlier time due to her moment of inertia decreasing, because when she tucks, her mass is going closer to her axis or center of mass, which means the moment of inertia would become smaller. What if air resistance was included? Her horizontal distance would then decrease due to the air pushing back against her body, which then limits how far she can stay in the air. In conclusion, this successfully showed how 2 complete rotations in the air can be modeled through constant horizontal motion and how angular displacement builds over time using computational physics. Thank you.